Hello, am I audible? Hello, can you please confirm if I'm audible? Yeah, great, great. So just invite your friends, okay? So I'll be sending the certificate link at the middle only, not at the beginning or not at the end, okay? So let's wait for Ritesh, he'll be joining orals too, okay? So he'll be starting with hyperparameter tuning and I'll just give you a walkthrough of the project. Considering that I've already taught you all the codes, okay? Except model creation, I've taught you all the part. Okay, so yeah, now let's wait for some 5 minutes. Until then, yeah, you can just ask your questions. Okay, just ask. So here, if you see, we are going to use. Hello. So here, if you see, in RTX, like sorry, in models, we are going to use different models. As I said, I'll just show you. As I said, like I'm not going to implement it. Okay, so I'm just going to run the codes. As you know, like I've taught you all the concepts before itself, so I'll be running all the codes. Okay, so I'll be teaching you about cat boost, xzboost, and we have svm, knife bias, and there are a lot of other models also. Everything is scale and implementation, right? So that would not be that tough. I'm having some camera issues today, so I can't turn on my video. But Ritesh,
Yeah.
yeah, guys, I'll be first starting up with hyperparameter tuning today, and I'll be going with end-to-end project and certificates. As I said before, it will be given at the halfway, at the halfway of the project. It will be given. So yeah, I'll hand over the session to Ritesh, and he'll take over it. Okay. So possibly this will be the last session of taking for you all. Okay. Thereafter, it will be Ritesh who will be taking for you guys because uh, I'm going to take only the model creation which I took yesterday. So hereafter, it will be model deployment, ML ops, and all kind of an interesting session which Ritesh will take care. So Ritesh, you can just go forward. Okay.
Yes, yeah. Give me 2 minutes.
Guys, until then, ask your doubts. Just in data. Just put it. I'll just answer it. So today actually there are a lot of technical issues from my side. Okay, because I have relocated myself to a different place. So soon these errors will be resolved. But don't worry, because hereafter it's not going to be me who is going to handle your live classes. It's going to be Ritesh who is going to handle. And yeah, he has created an awesome material on hyperparameter tuning. So you will be having a good look on that. So once it is done, so yeah, we'll be moving into model deployment. So let's wait for a minute. Okay, Plotly and Dash. Okay, yeah, they are also plotting libraries, and some guys are preferring that. Yeah, even I love Plotly, but according to me, Cbon is a simpler library. Okay, so Plotly is not as simple as Cbon. So that's why I don't prefer usually for Plotly, because see, our ultimate aim is just to plot the graphs, right? The good thing about Plotly is you can also create dashboards by using Plotly. Okay, so if you want, yeah, you can use Plotly also. My reviews is good only, it's good for EDA. So it's upon your wish. See, there are a lot of things in our place, cufflinks is there, or else Plotly dash. Okay, Plotly dash is a single name. Okay, Plotly dash, Matplotlib, Cbon. Even you can do EDA by using Power BI, Tableau, however you want you can do. But it's upon finally you who is doing it. Okay. So yeah, so seems like there will be only one person who will get the certificate, I guess, because considering that I disabled the chat replay, so no one will be able to get after that. So fine, yeah, Ritesh, let's go on.
Yeah. So let me know my voice is clear or not.
Yes, it is clear.
Okay, okay, okay. Let me share my screen. Okay. So in the meanwhile, I'm not able to see your chat. So if you have any question, you can just drop onto the chat box so that I can take a look onto it. Okay, so let's move towards like hyperparameter tuning. So I think most of the people who are watching this tutorial must somehow done the hyperparameter tuning in like in ML projects. Like you have done the hyperparameter tuning. So what is hyperparameter tuning? Let me give you some kind of a example, small example. Let's say you are having a model. You are having your any model. Take any machine learning model like linear regression. So inside the linear regression, if I go to sklearn site, let me move towards the sklearn site. So sklearn, just go to sklearn. Inside sklearn, if you go to any model, the any model which is present, let's check the classification because our task is more towards classification. So let me take the elastic net. Okay. So these are the just kind of a similar models which are present here. So what we can do here, we can go to elastic net. Okay. So as you can see, there are a lot of parameters which are available here. Like there are alpha, there are L1 ratio, there is fit intercept, there is normalize, pre-compute, and most of the parameters like you only use 2 to 3 parameters, and most of the other parameters are not too much important, or you can say not to not play a better role or great role when you are performing, when you are building a model. So, in a similar way, if you take any model, whether it is a SVM, whether it is a random forest, or whether it is a cat boost, any model, you will see there are a lot of parameters are available. Correct? Now, let's say I have initialized alpha equals to 1.0. Default it is 1.0 as you can see here. Default it is as a 1.0. Now, I want to test with it. I want to play with this alpha value. I have, you can say I've changed this 1.0 and I have placed 1.5. Now I have got a slightly better result, you can say. After some time, I have again changed the value 1.3. I have got a much better result. But I don't know. I am a human. I don't know what which parameters, if you can say, which parameter plays the best role here, which parameter is important for us, which parameter, you can say, what is the value of that parameter that is the best suitable for it. So that is known as something called as tuning. Tuning means you are having a list of values. Let's say you have randomly assigned a value like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say you have assigned till 10. And now you have asked your model to just iterate over these all numbers and make a combination, make some kind of a combination. You all have studied some kind of a, you can say, permutation and combinations. In a similar way, we are having different parameters. Now different parameters have different list, different parameters have different list. Like at the alpha we are having 1, 2, 3, 4, 5, 6. L1 ratio we are having another 0.5, 0.2, 0.4, 0.6, 0.7. In a similar way, we have a lot different parameters are available. You can say different values of parameters are available. Now I need to make such a better combination. You can say I need to make such a combination that it will be helpful for my model. You can say it will give me a good score, good accuracy score, good RMSE, good MAE score, depend on whatever task you are doing, whether it is a classification or regression. So that is the thing. If I show you the tutorial, it will be much more clear. So I hope it is, you are now knowing what is hyperparameter tuning. So hyperparameter tuning is nothing, but you can say we are making some kind of a good combination. Good combination from, you can say, by choosing a different parameters from a list, or you can say like I'm having alpha, L1 ratio, fit intercept, normalize. So what I will do, I will just experiment. So the package which I'm using, let's say I'm using randomized search. So what it will do, it will random search. It will make a combination of different parameters, values. Like at the first, it will take 1.0 with 0.5. Again, at the second, it will take 1.5 with 0.6, and it will compare. At the end, it will compare and see which is giving me the better result. And then after comparison, it will show me the, like, these are the parameters which are best suited for your model. So this is known as a hyperparameter tuning. Any doubt in it? Let me see any question, if you have any. Yeah, any question you can drop onto the chat so that I can take a look onto it. If it is clear, just type clear onto the chat box so that we can move forward towards our you can say tutorial which we are having. Okay, so if you have any question, you can drop onto the chat box. Okay. Now let's see about about different types of packages which are available into the market, which we can use for hyperparameter tuning. So it depends from task to task. In sklearn, sklearn provide their two libraries which are available. The first one is randomized search CV. So what is CV at the end? CV is cross validation. CV is known as cross validation. I hope I have also discussed that cross validation into the previous sessions, where I've told you like what is k-fold cross validation, what is stratified k-fold cross validation. So this is, you can see it is known as randomized search cross validation. To improve the accuracy of your model, to improve the performance of your model, we are performing some kind of a internal splits. While searching for a best parameter, we are performing some kind of a internal splitting. So for that, we are using cross validation here. Now let's search for randomized search CV. So this is provided by the, you can say, sklearn. It is available by sklearn. Sklearn provide this library, randomized search CV. In a similar way, you can have a there is another library known as grid search CV. Grid search CV, randomized search CV. These two are the libraries which are provided by the sklearn when you are performing some kind of a hyperparameter tuning. So these are the libraries which are present in sklearn. In a similar way, you are having another libraries also, like uh, halving grid search CV. So it is, you can say, it is not too much used, but it is, you can say, you can give it a try once you feel confident with grid search CV and randomized search CV. So these two libraries which we are going to see today. Another library which is available into the market for, you can say, hyperparameter tuning is known as Hyperop. Hyperop is the another one. So you can say this is the another library which is present in the market. So Hyperop is, you can say, is one of the package which you can see here. It is also used for hyperparameter tuning. So it is, these all are, you can say, are the advanced libraries which are present, which can work more better, which can give you more better visualization, which sklearn don't have. So, but at the end, we are going to first try with sklearn libraries like randomized search and grid search, and then we are going to move towards Hyperop. Then at the third, we are having Optuna. So Optuna is the another library which is, you can say, is one of the best library which is present currently. So you can see here, Optuna is a automatic hyperparameter optimization software framework, particularly designed for the machine learning. It features an imperatively defined by run style user API. So it is, you can say, this is the library which is currently one of the best one, which is currently present as a, you can say, uh, one of the best library in the world of hyperparameter tuning, Optuna. So you can use this. We are also going to see this Optuna. It has a lot of features. If you see their tutorial, if you see their key features, so they are performing, you can say, when you are going to run grid search CV or randomized search, sometimes it takes a time, sometimes it takes a lot of time to search for a particular parameter, particular perfect, you can say, parameters. But Optuna is, you can say, is one of the fast one because of the some kind of a parallel processing. If you go to, if you search for parallel processing, so there are a lot of, you can say, parallel processing softwares are present, and that softwares, you can say, it Optuna is one of the similar to that softwares, like the software like PySpark is the software which is used for, you can say, for performing parallel processing of a data in different clusters. So you can say this library also has that capability of performing parallel searching of the perfect parameters. So if you want to learn about this, we will have a note. I'm having a great notebook here. So I will also share some kind of good resources at the end so that you can also take a look onto them. So this is their best tutorial which are available, like lightweight versatile platform. So you can take a look onto these all examples which are present here, so that you can implement them by your own onto your projects. Now let's see a small tutorial over what is hyperparameter tuning. Okay, just starting the tutorial. If anyone have any question, you can drop. Okay, okay, stratified. Stratified will be discussed. Stratified will be discussed. We will discuss. K-fold and stratified. We will discuss. We have discussed K-fold. We will discuss stratified also. Don't worry. There is not too much difference. If you search for in Google also, so you don't get too much difference in stratified also. They will give you the same result. Okay. We will discuss stratified also. Don't worry. Okay. Anything question? Any more question? Anyone is having? Just drop onto the chat so that I can take a look at the end. Any question you are having. Yeah. So now let me tell you one more library which is present. Like if you want to, if you're training, like let's say you are training a Keras neural networks. You are using Keras to train your neural networks or build your neural networks. So in neural network, we are also having a lot of hyperparameters. If someone has a little bit understanding about neural networks, so we are having a, like you can say, learning rate, and you can say regularization, dropout, how much the dropout you want to set. So there are a lot of hyperparameters. If you search for a Keras documentation, you will get a lot of hyperparameters to tune. So in a similar way, we don't have any kind of a library which is present in the past, but nowadays there is one of the most popular library which is present, is known as Keras tuner, and it is by, you can say, TensorFlow. It is natively built by TensorFlow. So Keras tuner is here. Wait a minute. Give me a second. Give me a second. Okay, okay, okay. Sorry for the disturbance. Yeah. So difference between randomized search CV and grid search CV. See, there is nothing too much difference between both of them. Wait a minute. Okay. There is nothing too much difference between both. There's nothing too much difference between both of them, but like you can say, randomized search CV is used for, you can say, selection of parameters are done randomly. Selection of parameters are done randomly. And in grid search CV, you can say we go just, you can say, one parameter, then it is compared to another, then it is compared to another in such a way. When we are discussing that, you can get to know, like I will tell you what is the difference in tutorial. So let's see the tutorial. So randomized search, as the name say, random selection of parameters. And in grid search, we are searching by grid wise. So let me show you in the tutorial. So any more question, like can we have a presentation in the full screen? Yeah. Okay. Vasant, do one thing. There is a, yeah, there is a option to move me at the bottom. No. There is an option to move my screen, move me at the bottom corner.
Just a
Yeah.
minute.
Okay. I guess it is more clear now. Amartya, is, I guess it is more clear now. Yeah, it's good. It's good. Yeah. Okay. Now it will be much more clear. Okay. So let's see about some kind of a tutorial. So I'm talking about like Keras Tuner. So Keras Tuner is, you can say, is one of the uh, available thing which you can use, available tool which you can implement or use with the neural networks. When you are building deep neural networks, you can easily use this. It is very easy. Like sometimes you don't get like how much units we want to take, how much you can say in a particular layer how much unit I want to take, 8, 16, 32. You can even search for that when you are studying about the neural networks. And some of you might have been studied, so you can get to know like what I'm talking about here. So you can utilize it to find a perfect parameter for your neural network. So this is the Keras tuner. This is for, you can say, deep learning. This is meant for deep learning. Okay. So we have discussed Keras tuner. We have seen about some kind of a tools. So now let's see about some kind of a small tutorial over. And I'm using the same data set which Vasant has left at the end of pre-processing, after the pre-processing and used in the model building. So I'm going to utilize that data set only. So I guess my screen is visible to all of you. If not, let me know. Let me know if my screen is not visible. Okay, yeah.
It is visible.
Yeah, just say like if it is not, I can increase the second. I guess it's too large.
Ritesh, close that file tab, Ritesh.
Okay. Yeah, fine. Great.
Yeah, now
Okay.
slightly zoom it.
Okay. Yeah, I guess
Now,
everything is clear now. Okay. Great. So these are some general imports which you can take a look onto here. Like I'm currently using xzboost. You can take any model which is present here, any model, or you can add any of your model which you want. Random forest classifier, decision tree classifier, any model you want. So I'm taking the xzboost classifier here. So you just need to import this, import xzboost as xgb, and then don't need to import this. Just import xgb classifier only. It will also work. Okay. XGB classifier here. Then you just a small kind of a dependencies which we generally import: sklearn.model selection, printf split, random forest classifier, cross validation score, simple simple vector simple vector classifier, load arrays, decision tree classifier, accuracy score, recall score, and these all like. And at the end, and this is the important one. This is the important one. Let me mark here. This is the dependencies for, you can say, grid search CV and randomized search CV. This is the dependency for grid search CV and randomized search CV. So you need to import this if you want to use grid search CV and randomized search CV. Okay. So we are having cross-file score, simple vector classifier, load arrays. So some of the dependencies are not needed, so you can also remove it from the notebook. I will share the notebook soon, so you can also test using your dataset. Okay. So now let's see about these all are the dependencies. Now here I am going to import the CSV. So just write pd.readcsv. It will be it will be showing you giving you the data frame, what data frame you are having. So here I'm having date, location, rainfall, evaporation, and all the data, all the features which we are having. So as you have taken a look, because you have done some kind of a pre-processing sessions with Vasant, so you know about you are well versed with the data set. So what I'm going to do, I'm just going to drop unnecessary columns which we don't need, and at the end getting the target value and feature value separate. Then x dot head, taking the top first columns 0 to 4, top 5 columns. Then this is just a trend test split. With a, you can say you can increase the test size, but just I have taken this amount of test size. You can consider it as a any, like you can even change it. You can even change it according to your purpose, 15% or any. But don't make a unbalanced data set distribution. Just make a balanced data set distribution, so that your model should have a good score, good confusion matrix. Yeah. Okay, so let's run this, and then we can get some kind of a. We have splitted our data, the features and the target onto X train, X test, Y train, and Y test. Okay, so then initialize a classifier as we what we do generally. Then for a scene purpose, just showing you the values which are present here, like 0, 1. We are having a binary classification problem. Then this is the thing. This is the actual code. This is the actual code. Now, what is going on here? Like, we have created a one kind of a, you can say, a list. Inside that list, I am having a kind of a dictionary. I am having some kind of a dictionary. So inside the dictionary, I have mentioned key value pairs. I have mentioned the key value pairs. The first one is learning rate. So how I got these all parameters? How I got these all parameters? From the documentation. If you search for the xzboost documentation, let's go there and see, like, just search for xzboost docs. Okay, then go to parameters. Then go to parameters. Inside the parameters, now you can see a lot of things here. Booster, verbosity, validate parameters, and thread, numpy buffer, and lot of things. A lot of parameters for the tree booster. You can see here different types of parameters. So what we have done, we have taken some kind of a general parameters which we
Hitesh,
need. Yeah, yeah.
can you please put the collab link in the chat with the
Yes, yes.
share like viewer access
Yeah.
because they want to run side by side
Wait,
exams.
wait a second. Wait a second. I'm putting. I guess you all have dataset. I guess.
I think you can also share that thing, Ritesh,
Okay, okay, okay. Yeah,
put
yeah.
it in a V transfer and then send the V
Sure,
transfer.
sure, 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 sure.
And guys, I'm now putting the form link for certificate. Okay, just fill it. If you fill that only, I'll be able to provide the certificate. And don't worry, don't rush up on the certificate. Okay, I'll be giving only after the bootcamp ends. Okay, so but for now, you can just fill this
Vasant,
form and see and
Vasant,
say if
Vasant,
it is okay.
Vasant. I've shared onto the private chat. Just take a look and
Yeah,
share with the
yeah.
audience. Okay,
Hmm.
for the dataset, let me give you the dataset. Wait a minute. I guess it is present here. So what I can do, I can go to vTransfer, transfer, and okay, just want to send the files. Uh, Wait a minute. Okay, give me a second. Okay, I guess you all have got a notebook. Can we get this code while? Yeah, you have the code. You can along with you. You will also get the dataset. Give me a minute.
guys, until then, just see and say if the form is working. Okay. Uh, just see and say.
Just a second. Okay, so here is your link. You can download the pre-processed dataset also. Just drop it onto the Google Colab and run it. Okay, just share the dataset to the audience. Listen. Yeah. Okay, so coming back to our topic. Okay, so here we have created one kind of a list. This is a list. Inside that list, we have created a dictionary. We have some kind of a parameters. So how I have got these all parameters? I've gone towards the documentation of the xzboost. So in the documentation of the xzboost, there are a lot of parameters like alpha, lambda. These all parameters. So what I have taken? I have taken the important parameters, which are used by, you can say, common, which are very common, which are, you can say, because there are a lot of parameters. Some of the parameters we also don't know. There are a lot of parameters are available, right? So what I've taken the important parameters and just use them into my grid cell CV for parameter tuning. So you can say learning rate here, I've started with 0.05, then 0.10, 0.15, 0.20, 0.25, 30. You can even increase this list according to your purpose. You can increase this list. There is nothing a, you can say, stop or you can say end. You list according to your purpose. Then I am having max depth. So max depth, again the same thing. You can take a look onto this parameter, go to the xzboost site. Here you can search for max depth. You will get to know about the max depth. We are having a max depth parameter. Default it is 6. Now how much you can increase? Like in some of the parameters, you can see, you will able to see the range. So what its range is? 0 to infinite. So you can add, you can increase the list according to your purpose. You can add 6, 7, 8, 9, 10 till infinity. There's not any end. Then in a same way, gamma. Gamma is the another parameter, min child weight is the another parameter, and call sample by tree. It is the another parameter which is present into the documentation. You can similarly search for them and take a look what this parameter is. Is it suitable for my, you can say, for my model, for my code? And you can even take a look onto the range. Its range. It is from 0 to infinity. So you can say 0 is the only accepted in the loss guide. So it will give you each and every reference. It will give you each and every reference in detail. What parameter you want to use, what parameter is not important, what is the default value, what its range, each and everything. Then after selecting the parameters, now this is the, you can say, a suggested process. You can say people are doing this kind of a process. They are creating a list. Inside the list, we are having a dictionary. You can even create another you can say, you can another you can use a list, you can use a dictionary. It depend upon you. So this is the way how how I have written the grid parameters here. So now after doing the grid parameters, so let me make some kind of a comment here. Okay, so grid params initialize. We have initialized the grid parameters, correct? Now, after initializing the grid parameters, now we are going to first perform randomized search CV. So I guess I have run this whole thing. Okay. Okay. Now this is the, you can say, it is the initialization of randomized search CV. Inside that, the first one is estimator. You can just hover this up. You will get a guide. This is the guide. What all parameters are present inside it? Like parameters, estimator, param distribution, scoring, and iteration, these all. And jobs, pre-dispatch, a lot of parameters are present. But again, we are going to take the parameters which are important to us. Okay. Now, here we are taking randomized search CV. We are having a classification problem. In a similar way, you can define your own scoring metric. You can take ROC AUC curve. You can take accuracy. You can take recall, you can take the precision, any other metric which you want. But just keep in mind, it is available inside this package. How you are going to do that? Check their documentation. What all scoring parameters are available here for a or for a regression model? What all scoring parameters are available there? Now, param distribution. Now, this is the important thing. This is the important thing. Here we are going to initialize our parameters. You can say this is the stuff which we have created, grid params. It needs to be initialized, correct? So to initialize them in the RandomizerCV, we write param distribution. So I just given grid param. So in some people are just putting this whole dictionary there. In some places you find people are using some kind of a variable, initializing some kind of a variable here. So I find this kind of a method pretty good. So that's why like I have chosen this method to work with this. Okay, then number of iteration. How many number of iterations you want? Either 5, either 10, either 20, either 30. This will tell, like you can say, this will tell the randomizer CV to search for the definite perfect parameters n number of times, like 5 steps. You can see it is similar to 5 iteration. Search for the perfect parameters in 5 steps. After 5 steps, just stop and give me the best result. After comparing all the results, like comparing one with 2, comparing one with 3, comparing one with 4, in a similar way, apply all the combinations which are making here, which you are making here. Now n jobs. N jobs, this is the parameter which is optional. You can say you can use this parameter. Let's see here what this parameter means. So this parameter, because they have a best definition about n jobs. So n jobs means you are also utilizing some kind of a their memory, I guess, because I have also not remember about n jobs. So let's see about what is n jobs here. Okay.
N jobs means how much cores of your system we
Yeah,
consume for
yeah,
this
yeah,
process.
yeah. Course, number of course. Okay. So then we are having cross validation. So cross validation is equals to 5. So we are taking the 5 folds we are making. So here we have taken the 5 folds. You can see you can split your. I have shown you the image. Like we are splitting our data. Let me show you again that image, so it will be more clear. So k-fold cross validation. Okay. So inside the k-fold cross validation, here you can see this is the 5 folds. This is the 5 folds with 5 splits. This is what we have initialized here. Cross validation equals to 5. We are having a 5 folds. Now verbosity. Verbosity is the term which tell you like to get a expand output or to get a low output. You can say when you are running something onto the terminal, you will if you there are different ways. Like if you place verbose equals to 1, some it will say silent, means it will don't show you the result. It will only show the end result. Verbose equals to 2, it will show the whole process, whole you can say processing, what is going on at the back end. So this is what it is meant by verbose, and there are a lot of parameters which are available onto which you can work. Like here it is a guide, a whole sort of a guide which is present here, so you can take a look. So here like n jobs is also mentioned, number of jobs to run in parallel. So we are running, so if you are having 1, so it will say none, means you can say 0 jobs are running. And if you are having -1, then you can say some jobs are running. You can say you are allowing the parallel processing of the data onto a CPU. So that is n job. So it is having a different parameters like 1, -1. You can take a look from their documentation. Okay, then randomized search dot fit, same thing which we do in the classifier. Randomized search dot fit, we have fitted our you can say model. We have taken the prediction onto the test set. We have got the prediction onto the test set. Compare the best score. Best score, you can say best accuracy among different kind of models. You can say among different kind of parameters. Let's say our model sometimes get let me show you. Our model sometimes get 0.05, sometimes 4, 0.31, and 0.2. It has made this combination. Now it will give you the accuracy. It will give you the accuracy. In a similar way, after performing 5 iteration, it will go for best score. check the best score by doing some kind of a combination, comparing from, you can say, comparing first iteration with second, second with third, third with fourth, fourth with fifth. And after giving the best score, it will also give you the best parameters. And this is just a formatting to give you a good result onto a screen. So let me run this, then we can have a good idea about it. Okay. So now here you can see 5 folds. For each 5 candidate, total 25 fits. If you go here, 1, 2, 3, 4, 5, 5. This is, sorry. Count from this split. Split 1, split 2, split 3, split 4, split 5. These are 5, these are 5. 25 candidates are present here. Correct? 1, 2, 3, 4, 5. And this is whole, a matrix of 5 cross 1, 2, 3, 4, 5, and 5 cross 5. So you can get a 25 candidate here. In a similar way, it is doing that thing. Like 5 fitting 5 folds for 5 candidates, totaling of 25 fits. Now we have specified the parallel processing, so it will do the parallel job. -1 specify the parallel processing. If you specify the another number which is given on the documentation, it is meant for none. So you are not allowing the so why we are doing parallel processing here? To make our process fast. Now it will give you the result. Wait a second. Okay, it is done because you can say our data set is not too. It has given us the result. Okay, 87.96. These are the best parameters. You can say these are the best parameters which we are having. Any doubt till now? Like I have shown you the randomizer CV. Any question you can drop onto the chat. Any question you can drop onto the chat. Yes, -1 implies that you can say some kind of a core processing, your CPU cores. Okay. So if you have any question, you can drop onto the chat so that I can take a look onto them also. Okay, so this is about the randomized search. Change the name from here, you will get the grid search. Let's place the name of grid search. They are very similar. Nothing to change that place. Just place their name here. You will get a grid search. CV, wait a second. I guess, wait a minute. Let me place grid search. So let me run this. If it shows some error, we will fix it. Okay. And it got the param distribution. Grid search CV has a separate thing. Let us see. Param grid. It has param grid. So let's make it param grid. Grid. Okay.
So guys, one thing to noticeable here is we also make mistakes, right? We also make mistakes. We also refer from Google. We also do everything. So it's not like we'll at the first stage we'll get everything. No, it's not going to happen in case of us also.
Yes, yeah. Yeah. An iteration. Okay. Will also end jobs, scoring, param grade, CV per dispatch. Okay. So let me mark this as that. Okay. Now let's end this. Okay, now this will take time. This will take a lot of time. Now, and I've shown you how to debug. Na? So you can also debug in a similar way. I have not written a code for grid search CV. You can just take a look onto their documentation. What all things are different here? Like they have parent distribution, we have param grid. There it is present as a param grid. So in a similar way, you can search for just hover there. Just it is a very similar, like just hover it onto it. So now this will take a lot of time because grid search CV is very heavy. You can say it is very computation. You can say it takes a lot of time. You can say 5 folds for each 5,400 candidates, totaling 27,000 fits. It takes a lot of time. Okay, so what we can do, we can reduce the folds.
27,000 feet. I hope you all get it, guys. Like, you are fitting it one time. Like, SVC dot fit,
Mhm.
which means it is one time. So here you are doing 16,200 fits, which is a very, very huge score.
Yeah.
Yeah. So, yeah, it will take even hours and hours to run this session.
Yeah, that's why grid randomizer CV is like good. not
always the
like
preferable option.
yeah, yeah, yeah. It will take a lot of time. You can say I've reduced the folds also. So then also it is choosing
So Rajat,
16,200.
just keep two folds alone, okay?
Okay, let's see.
Two folds and just a minute, come down. Yeah, it's huge. Yeah, it's huge. That's why we are doing hyperparameter, right? 10,800. That's also very huge, right?
It will take a time. You can what you can do. You can just experiment onto the parameters using grid cell CV. Let's move towards Optuna. Let's move towards Optuna. Okay. So I'll stop this because it will take a lot of time. What you can do, you can just experiment onto this. Experiment onto these all. Just change the number of parameter. Just change the. You don't need to change anything. You just need to sit for hour. You don't need to change anything. You can experiment onto these all parameters, and you can take a good scoring matrix here, a more according to your preferred. Then you can change the say predict option, and you can work upon it. You can play with it. Okay. Now this is the, you can say, I guess we have stopped it, so it will be not. We are having randomized search here, so that is for it. So confusion matrix is for it. Like now currently it is not showing the good result because we have not fitted our model onto grid search CV completely. We have not filled onto the all the folds. So it is just a, you can say, confusion matrix. Confusion matrix you can plot after getting a some kind of a prediction after fitting your model onto the perfect parameters. You can get a confusion matrix. This is for you. You can just try with it and change the parameters, get a good confusion matrix. Then you can show to us onto the group. Yeah. So this is Optuna. Now we are going to see the Optuna. So the first step is to go with installing the Optuna. Just install the Optuna. So I've already installed. So I'm not going to install it again. So it will be already installed onto this notebook. Just import the Optuna. Then I'm taking the fresh data frame because like we have done some kind of a experiment onto the above data frame. So I've just loaded the same data frame again. Okay, performing the same operation, splitting my data set onto the onto the target and feature. Now this is the function. This is the function. Now what is objective? You can say when you are learning the probability. Everyone is familiar with the probability. So we are having trials. We perform some kind of a trial. Like we are, you can say, throwing a coin. So what are the trials are available with us? Either head or either tail. So we are going to write all the possibility in the trial option. So trial is, you can say, what Optuna has done. Optuna has chosen some kind of a method. Like they have created one keyword known as trial. So what is trial? It will try different parameters and make a perfect combination. Now what its objective is? So this is just an objective function. We have created an objective function here. Now, in a similar way, this is just a whole definition of a function which is available onto their documentation. If you go to the Optuna documentation, it is available. You can customize it, you can use it according to your purpose. Okay. Now, here is the trial. Here is the data equals to X. Data means, sorry, data means features. Target means, you all know what is target. Okay, now splitting the data into the train test split. I have taken 15% of the test size. You can take any, but don't go with, you can say, don't make the data set fully imbalanced. Okay, then I'm creating a param grid. This is similar to the randomizer CV or a grid search CV. What we do, I'm creating a dictionary. Inside that, I am having some kind of a key value pairs. Tree method, GPU hist. So what is GPU hist? GPU hist is used to utilize the GPU. Let's say you are utilizing the CUDA. You are utilizing the let's say you want to utilize the CUDA. CUDA is, you can say, in NVIDIA we are available with CUDA cores. So for that you need to set up the CUDA first. In a similar way, if you want to utilize the GPU for our training purpose, so we need to initialize the GPU first. So here we what have done, I have initialized the GPU first here. Okay. Then these all are the, you can say, parameters which are available onto the xzboost documentation. You can see here gamma, ETA, min child weight, max delta step, all each and everything is mentioned here. Now what what is trial dot suggest log uniform? It is used for continuous values. It is used for continuous values. Optuna has two things. Let me show you what is into their documentation. So Optuna has some kind of a trials. We are using some kind of a trials. Wait a second. Okay. So Optuna has trial. So I have told you what is trial. You all have studied the probability. Let's say I want to I'm throwing a dice. So you can say how many possible cases are present. Either I can get one, either I can get two, three, four, five, till six. In a similar way, we are having trial. So it is used for trying different combination of values. So you can see this is the definition of trial, which is little bit tough to understand. That is like I have explained you. Now, then we are having these all methods are available inside it. Now you can take a look here. Like report is for, you can say, report an objective function value for a given. So whenever we are taking objective function, so it is I'm saying about this function, this. Okay. Now inside that there are different parameters. Like we are having suggest dot log uniform, suggest a value for continuous parameter. Suggest dot uniform, suggest a value for continuous parameter. Same thing. You can use log uniform. You can use uniform. There is the same thing. Now, what it expect? The first thing is name. Second is low. Third is high. So that is what we have given here. Like the name. What is the name of the parameter? What is the high value? Let me see. What is the low value first? What is the low value and what is the high value? Okay. So these all things we have taken. You can say this is the general definition of Optuna. General definition of Optuna we are having here. Okay, then in a similar way we are having alpha, trial dot suggest, log uniform, alpha, and this is the low value, this is the high value. We are giving a particular range. We are giving a particular range. Try all the values which are coming between this range. Now, how awesome this is. Now, in the grid search CV randomized search, we are bind with, you can say, some basic values. These all values. We need to write them. Now, if we are able to give a particular range here, like we are giving a range from this to this, then it is how much good it is for us. Like in a similar way, this is the continuous value. Lambda is a continuous value we have given in a same way. Now, for categorical value, we are having this suggest underscore categorical. So it accept name and then choices. What all choices you are having? So in a similar way, here we are having name and then a list of our choices. Here we can't give that low to high range. Here we can only give our choices. Now in a similar way, let me scroll this here. In a similar way, we are having these all. An estimator is a, you can say, we want to hard code this value. We don't want to change it. So that's why we have keeping that as a 4000. In a similar way, now you can get here like suggest int. So it is integer value. We need to suggest some kind of integer value from this range, from 1 to 300. And how I am getting this is integer value? Refer to doc. If you are min child weight, it will tell you the data type of that particular, you can say, parameter. Now, after that, initializing the XGB classifier. This is, you can say, if you studied about the args and quags, you know about what we have done here. So this is the basic Python, initializing the args and quags. So after initializing our model, then same thing, fit, perform early stopping. Early stopping means if we are not getting good result, just stop it. If you are not getting the good result. Why we don't want to go to you can say we don't want to finish our whole iteration. Just stop early. If you are not getting, or you can say if you are getting the same result again and again. Now verbosity equals to false. This is, you can say, We don't want to get a full output. Full, you can say, full logs, whole logs. We don't want to get the whole logs. That is why we have mentioned this. Now, this is predict. We are predicting onto the test set, getting the accuracy, returning the accuracy. I hope it is clear to everyone. Now, just run this. Uh, but first, let me change one parameter. If I don't, okay, this is just a function. Just run it first. Okay, I am taking for showing you. Just take the 5. Now it is good. Okay. A new study is created in memory with this name. Okay. It works on study. You can see it whenever you initialize this study equals to optuna dot create study, it will create a new study. Again, it will create a study of unique ID. So it is very good. Like it is. Now let's see what all things it has shown, and we will wait for it. Till then, if you have any question, you can drop onto the chat. Any question you are having, you can drop onto the chat. Now this will show you. You can say after this, I have a very good thing for you all. Like a very good illustration, graphical thing for you all. Just see. Let's see how much time it will take. It will take some time.
There is a question with this. Let's check it.
Yeah, yeah. Okay, it's up to. Yes, it is faster. It is faster. It. You can see like it has shown you the trial first. It has given you the trial first. Grids are CV even not shown you the trial first at that time in such a way like trial 0 finished, got an accuracy of this with parameter these all, and at the end it will give you the best trial, and at the end it will give you the sum of the all the trials. You can say the best one it will choose. Now it will go very fast. It will go very fast. Just wait for a second. Wait for some time. We can give 5 to 10 minutes. Till then, if anyone have any question, you can drop. Trial 1 is also done. Trial 1 is also done. Okay, let's see what all things we are having.
They are asking, is there any drawbacks here?
No, 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 no. See. Optuna is not drawbacks. Like I have not faced any kind of a drawback. It is good. Like it is good for your all purpose. If you are using, you can say, uh, your task is hyperparameter tuning. Good. It is very good for that. Very very good for that. You can say it is also fast. It will also give you a lot. It will also give you a lot of option. Just give me a second. Yeah. I hope you all are seeing my screen. Okay, so it has given the result. It has given the result like number of finished trials, 5, and best trial is you can say lambda equals to this. How fast it is like the people who are missing this session is like you can say it is a gem like we have discussed 3 libraries till now, and if we find time, I will also discuss Hyperop in the next session definitely. And this library is very good like how much you can say each and every comparison it has given you best in the trial 1, trial 2, trial 3, trial 4, and so on. It is one of the best. Now let me show you some kind of a cool visualization here. See this. Let me. Okay, see this. Now you can see this. How much cool is this? Parallel coordinate plot. Each and every value is compared. Each and every parameter value is compared with each and every iteration. You can see. Okay, okay. So you can see here, like we have done each and everything. Like, okay, give me a second. Yeah. So let me share my screen again. Okay, I hope it is visible. Like, wait a second, wait a second. Let me tell the Vasant to give me the access. Okay, wait a minute. Okay, okay, okay. It is visible. It is visible to everyone, correct? Just tell me. There is some kind of issue. That is why, like, I have to go. Okay. So we are here. Like, you have seen like parallel coordinate plot here. How cool is this? Like, you can even check each and every parameter. Each and every. You can check each and every parameter. Like here, you can even draw. You can say. You can see. You can see it. Make a, some kind of a comparison between them. So this is, you can say, parallel coordinate plot. Parallel coordinate plot. Now let's see the optimization history. Let's see the optimization history. This is the way how our model has started with this best value, and model has started with this lowest value, and it has grown towards, as the number of trial passes, it has grown towards the best value. This is the best value. Okay. So this is it from my side. Any question you all are having, just will answer them. Yeah. Let me also bring the Vasant onto the stage. Okay, okay, okay. Yeah, yes, ma'am. Okay. Yeah, Vasant. That is it from my side. Okay,
Yeah,
any.
so I'm taking the end-to-end project discussion maybe today or tomorrow or day after tomorrow. Okay. So because it's already 1 hour, I don't think you will get a tutorial really, guys. Like you won't get a hyperparameter tuning this kind of tutorial because it's a very detailed one he has shown there now. Okay. So actually we planned it for 20 to 25 minutes only max to max, but yeah, it gone till 15 minutes actually. So
Yes, yes, yes.
yeah, not an issue. Maybe tomorrow or day after tomorrow, based on our time convenience, we'll do the project. Okay.
Yeah, you can try hyperparameter tuning onto every any ML project where you are having a parameters. You can tune it. You can tune it
Ritesh,
anywhere
I
you are
think you
having
can stop
parameters.
your screen share. I think Ritesh, I think you can stop your screen share.
Yeah, yeah, sure. Okay, so wherever you are having parameters, you can tune it. Not a worry.
And I can see only three responses. Lakshmi, you haven't responded yet to the form. I think you were keen enough to look into the class, I guess. So, do reply to the form, okay? So, be sure that you are answering all the questions because that will show how much you listened to the bootcamp and how much you understood actually. Thank you so much, guys, for all wonderful sessions. Thank you so much. Yeah, don't worry. Still, we have some long way to go. First, we need to complete this bootcamp. So, in futures, we'll be doing some other bootcamp. So, possibly if Ritesh is available, he'll come, or else I'll also invite some other guests. I'm also having some other guests also. So, and another one announcement: Ritesh is having an interesting session on GitOps this week Sunday. Okay, just have a look onto his channel. So he's having a session on that. So the link is in the description. Just have a look on that.
Okay, yeah, yeah. Hi everyone. So thank you for joining us today. Have a good day ahead. Yeah.
Yeah. So if you just share it with your friends and So the guys who have been watching this as a recording, so I'll say one thing. Okay, the certificate link will not be available for you because I have disabled the chat. But if at all you need this certificate, okay, just come into the Telegram group and ping there. Okay, and there I'll reply for sure, and then after that, seeing some conversation, we can provide you the certificate. Okay, we don't have an issue on that. So yeah, so share it with your friends and communities. Okay, and if you have not liked the video, just like the video and subscribe to this channel. Okay, thank you all. Bye.